method of elimination. How does the method of elimination work? So here in type 3, which is example 3 here, I'm going to show you again how to use method of elimination with the combination of some of the basic mathematical operations and bring them all together to solve a system of equations. So guys, please bring your attention to this particular example. Now, if you look at this example, something that just right away kind of pops out to us is the fact that the coefficients for each of these x and y's for both the equations are completely different, and they don't even have you cannot just get rid of one of them by adding or subtracting right away, correct? So, and again, the other thing you can see here is like you cannot just multiply one equation by something to make it look exactly, to make one of the coefficients look exactly like the other one, right? So please have a look at these two equations. This is slightly more, little more complicated than the previous two types. And I think for something like this, again, you can still use substitution method because it's a valid mathematical method. But for something like this, I think it makes sense to use what we like to call as method of elimination, to get rid of one of the variables, eliminate one of the variables, and then solve for the other one. Again, then we'll still have to use substitution in order to find the other variable. But let us think about ways that we can make, one of the variables, one of the coefficients in front of one of the variables equal to each other with signs opposite, so that when we add them, we can just get rid of it. And we know what are the tools that we have with us. We have addition, subtraction, multiplication, and division as well. Well, the three things that are very useful here are addition, subtraction, and multiplication. Sometimes we may also have to use a division. So you may see an example where dividing by a number would make an equation simpler and would make one of the coefficients equal to each other. So you may want to use division as well. But in this case, it seems reasonable to think about using multiplication as a tool to get one of the variables equal to each other. Now, it's up to you which variable you want to work with. Let's say here we want to work with the x variable, and we want to basically eliminate the x variable. Guys, if we want to eliminate the x variable, just simply adding or subtracting will not do it for us. So what we need to do is we need to get the coefficient in front of x look opposite of what is the coefficient in front of the other x on the second equation. So which basically means that this and this, when we add them, it should just cross out. Okay. Now, how can we accomplish it? It is not too difficult. It's very easy to accomplish that. Guys, if I multiply this first equation by the coefficient of x, okay, so let us see what happens if I multiply the first equation by the coefficient of x, and let us ignore the sign here because we want one of the equations to have positive sign in front of the coefficient and other to have a negative sign, so that when we add them, they just cross out. So let us multiply the first equation by 5. Just let us ignore the negative, just multiply by the absolute value of that coefficient, which is going to be 5. Okay, so if I do that, and I'm going to rewrite this, and then inside my parentheses, I have the equation, which is 4x plus 3y. Of course, if I multiply the left-hand side by 5, we have to multiply the right-hand side by 5 as well. 11 times 5, I can already write that as 55. Let us simplify this further by distributing 5. So what do I get? I get 20x plus 15y equals to 55. This is my transformed equation 1. Okay. So this equation transformed into this equation by multiplying by 5. And why did we get that 5 from? We got that 5 from the coefficient of x in the second equation. Now we want to, if this coefficient is 20 in front of the x, we want to make this coefficient negative 20. Then if we add them, we'll basically be able to eliminate the x values, right? So how can we accomplish that? How can we make this negative 5 or the coefficient of x here negative 20? By simply multiplying by this 4. Okay, well, you already know how to get negative 20 from 5. You just multiply by 4, but you don't have to really think about that 4. That 4 is already here. That's the coefficient of x in the first equation. So basically, what is the idea? The idea is to multiply the first equation by the coefficient of x in the second, and the second by the coefficient of x. You just only have to be careful with the signs because you want to have one positive and the other negative. Okay, so if I multiply this by 4, and I'm going to write that step here because we are trying to do it for the basically for the first time, so I'm going to write the steps. But once you know what you are doing, you can kind of skip some of the steps. So 15 times 4 on this side would be 60. So when we simplify this, it is going to look like negative 20x plus 8y equals to 60. Guys, this is my equation to transform into this equation. So now I'm going to bring these two equations next to each other, and we still have to follow the same rules of aligning vertically the x's together, y's together, and the constants together. But no more am I going to work with this first and second equation. I have the transformed equations. I'm going to work with the transformed equations. So my first equation is 20x plus 15y equals to 55. And then my next equation is minus or negative 20x plus 8y equals to 60. Guys, from here we already know, like, we just have to simply add these two. And how do I know I have to add these two? Because we already know what is the next thing that we want to accomplish. We want to get rid of one of the variables. We want to eliminate one of the variables. In this case, how can we accomplish that? Just by simply adding. Okay, guys, again, there might be a situation where one has to subtract. Like if I here multiply this guy by negative 4, so I will have negative 20 and negative 20, then I'll have to subtract them. But again, when we subtract something, things may get a little tricky. So in order to avoid that, I like to keep it as like just adding those two equations. I want to make sure that one of the coefficients is negative of the other one, is opposite of the other one, so that by adding we can right away eliminate it. Okay, so when I add these two, when I add them vertically, this crosses out, and 15 plus 8 is 23y. And when I add these two, what do I get? 5, and it's 115. And now to get y by itself, I got to divide both sides by 23. 23, this crosses out, so y equals to, and when I divide this, I get y equals to 5. Once I have y equals to 5, we all still have to find the x value. Now to find the x value, you can go back to this equation or this equation or this or this. You have 4 options. It's up to you. It's up to you which one you want to use. I'm going to use number 1, guys. I mean, you can try using number 2. You should still be able to get the same value for x. So I'm going to use 4x plus 3 times y, which in this case is already 5, and that equals to 11. Let us simplify. We got 4x plus 15 equals to 11. Subtracting 15 from both sides, what do I get? I get 4x equals to 11 minus 15 is negative 4, and dividing both sides by 4, what do I have? I get x equals to negative 1. Guys, I have the value for x and y, and I'm going to bring it together here, and my solution for this system of equation is x is negative 1 and y is positive 5. Of course, you should go ahead and you should basically verify this solution as well. But guys, this is the method. So to bring it all together, there's 2 key things. One is the idea of eliminating, which means you want to get rid of one of the variables. And then how can one accomplish that? One can simply accomplish that by recalling or going back to like the basic idea of using the basic mathematical operations. And we all know the basic mathematical operations. The 4 basic mathematical operations are addition, subtraction, multiplication, and division. So guys, in these examples, we may have only used addition and multiplication. But guys, there could be times when you want to use subtracting or you want to use division. So again, it depends on a particular problem. So as I always suggest, before you start working on the solution steps, please look at the problem carefully. Spend some time, 15 seconds, 30 seconds, a minute, and then decide which method, which operation would be the easiest and the most sophisticated or most efficient method to solving a system. Okay, so I'm going to stop here for this method. In my next video, I'm going to talk about some special cases. So we're going to talk about two special cases, and then we're going to kind of bring it all together again, and then that would be the end of the solving the system of equations. We'll see if I get some like feedback from you guys. We can also talk about some nonlinear systems as well, which are not too complicated. Guys, things start to get a little more complicated when we have three equations, which is system of three equations. But let us first focus on two equations. Once we are confident learning how to solve two system of equations, then we can move on and understand how to do the three equations and more equations. Okay, so guys, till then, practice more of these problems on your own, and if you need, and again, if you need any help, let me know, and I'll be more than happy to help you with the system of equations or any other